Good afternoon, everyone. Thank you for joining us. My name is Austin Hypes. I'm the Chief Technologist and VP of Engineering for UNICOM Engineering. And today we're going to be talking about some of the latest security features available for server-based hardware appliances. So I'll spend just a little bit of time talking about UNICOM Engineering for anyone not familiar. But what we do is we service mainly software OEMs and ISVs who want to take their intellectual property, their software, their application, and bring it to market in more of an appliance model. So like a hardware appliance that an IT department or end user can purchase and deploy much more rapidly than just buying that software and figuring out how to provision it on hardware and manage that hardware. So with that, we actually do a lot of upfront consulting on an appliance design, the integration of that appliance with our customers' branding, including the documentation boxes, the system itself, global logistics for that platform to ship it anywhere in the world it needs to go, along with all the trade compliance that goes with it, and finally the post-sale support, so that if something goes wrong with that appliance in the field, bad hard drive, bad power supply, something like that, then we can make sure it's serviced globally with up to a 4-hour on-site support contract. So as a result, we work with a lot of software OEMs, many of which in the security market space. And with that consulting, we end up having a lot of conversations around how to better secure their appliances and also take advantage of some of the latest technology so that they're not over-provisioning hardware, they're not putting more resources than required to meet their goals. So with that, I wanted to talk about a couple of types of security. Starting with, and this really centers around kind of multi-chip standalone cryptographic modules. So that's a government term and FIPS 140-2, but essentially it's standards to define what makes a platform secure, at least from the government perspective. So first, we have platform security. So when we talk about platform security, it's all about securing the data on the system itself. So it also means, so in other words, encryption of the data on the system. It also means the secure elimination of sensitive data when that platform needs to be serviced. So let's say, once again, a hard drive or a storage device goes out in the system, needs to be replaced. You need to make sure that as that hard drive is replaced, it has no sensitive data that could potentially be compromised elsewhere on the platform. And also supply methods for secure key generation. Anyone who was at some of the keynotes today, you'll see that one of the things that was said is that it's actually very, very difficult to circumvent some of the cryptography and algorithms that are used in modern. So usually what's happening is people are circumventing it. They're finding ways to create copies of the keys or get around the entire encryption process. So it's very, very rare for someone to actually break the encryption. It's much more common for them to find an alternate means of getting the keys. So secure key generation becomes critical in a hardware appliance. Then the next piece we'll talk about a little bit is actual network security. So obviously the encryption of that data between two endpoints. So once the data leaves the system, ensuring that it's secure all the way to the last stage of the path. So a little bit of background. So major technology OEMs have been adding a lot of security features into hardware. So with that, Intel has been one of the forerunners of that and added many security enhancements right into the IA or Intel architecture of their modern platforms. So we talk about this is kind of combinations of CPUs and chipsets and other technology that ends up on your server motherboard in an Intel architecture system. Also, hard drive and solid state drive or SSD manufacturers have been coming out with whole lines of bulk storage products that have encryption built into them. So this is no penalty, always encrypt to the drive for very nominal cost increases over what most people are used to paying for nearline and enterprise class storage today. So we'll talk about that in some more detail. But also, one of the main things we always talk about these security enhancements is talking with our customers and is your code up to date? And what about many common packages that you may use as part of your appliance? Whether that's an open SSL package, things like your Linux or Unix kernel, Apache, your different cryptology file systems. It's all very, very important there because a lot of these enhancements, they come around every 12 to 18 months. And we find with a lot of our customers, they haven't done a main package of their operating system review, oftentimes in 2 or 3 years, and they're using much older technology that just by enhancing some of their packages or possibly moving to a new kernel or a new distribution, they can take advantage of a lot of new features that they might not be taking advantage of today. Also, by using many of these enhancements and doing those code updates, it can oftentimes reduce or eliminate the need for special dedicated security hardware in a platform. So we talk about these, they can be things like Cavium nitrox cards or other packet or security processors that might not be needed anymore if they can actually take advantage of some of these new hardware features. So what we see, and there's actually some source links in here, but performance improvements can range anywhere from 15 to 400%. 400% is more, you have not done any code enhancements for probably 2 or 3 years and are not taking advantage of many of the features available today. The 15% tends to be more, you've been keeping reasonably up to date, but you haven't taken advantage of the latest features here in the last generation of hardware enhancements. Also, along with that, with the massive increases in CPU core counts in modern Intel architecture processors, by taking advantage of this and moving a lot of things to their general purpose CPU cores from specialty hardware and ASICs, you can get a lot of performance improvements just in the multi-thread aspects. So if anyone's not aware, a common dual processor server platform today can have up to 24 physical cores, and that goes to 28 physical cores at the end of the year. So a lot more CPU horsepower than we had 2-3 years ago. So let's talk a little bit about that enhancing platform security with SEDs or self-encrypting drives. So this is fairly new, been around for about 18 months. Before this, you might have heard of FDE or full disk encryption, which did a similar thing, but it was kind of non-standards based, where SED is a much more standards based approach being taken by all the storage OEMs, i.e. the hard drive and SSD guys. So really what it does is it provides for bulk encryption up to AES 256-bit on all data coming into the drive. It's actually always being done. Even if you're not implementing a security key on your system, the drive itself is always encrypting the data, always at AES 256. Now, if you implement the security features, then it locks that down to only authorized people with authorized keys can access the data. If you don't implement the feature, it actually works just like a regular hard drive, and you never know that it's encrypting all the data in the background. But so how that works is the vast majority of modern BIOSes, as well as RAID controllers, are able to handle and manage those keys so that you can lock the system down and say, only authorized devices can access the data on these hard drives. And actually on the initial boot, the drive will present itself as a very, very small drive, usually a few hundred megs, which just has enough information for the hash, so it can determine if there's a trusted device connected to it, and if so, it essentially does a real quick reboot of the drive that then opens up all the data available to everybody. Well, part of that always encrypted means you have a crypto erase capability. So this is an crypto erase, that's another kind of FIPS term, but essentially what it means is that if you want that data to no longer be accessible, the system's going to be serviced, or you think there's some type of security breach where your software may see a unexpected chassis intrusion or something like that, you can issue a command in a very, very short period of time, definitely sub 1 second. It will actually eliminate the key that encrypts all the data. So all the data is still there, but now it is completely inaccessible to anybody. Even if you knew what the key was before, it's gone. So from government standards, essentially all the data on that drive is gone because you would have to break that 256-bit AES encryption to access it. There are also several drive options available that do meet the FIPS 140-2 level 2 standards. So these are actually secure cryptographic modules all on their own. Seagate is one of them. Toshiba is actually another one I didn't put up here. But what this allows is actual tamper resistance of the physical drive enclosure, to where if you tried to open the enclosure to maybe probe something later, it will actually destroy the encryption keys in the process. It allows for controlled access, but also includes its own hardware number generator. So the drive itself in the FIPS versions has its own 32-byte secure random number generator, which can even be accessed by the rest of the system. So both SATA and SAS versions of these types of drives are available, essentially from your 7,200 RPM, up to 4 terabytes a day, all the way to your 15K, 900 gig, 1.2 terabyte drives. Also very similar, most of the SSDs or solid state drives available today do have their own SED versions of them. So the same type of technology that you get on the bulk media, you can do on the solid state media. There are even FIPS versions of it available as well. And with that, if you have a system that needs to go in a harsher environment or needs higher performance than you would get on rotating media, you now have an option on SSDs to do that. Obviously a higher cost per gig, but much higher performance and much less vibration sensitive. It can handle higher temperatures than traditional rotating media. So talk a little bit about secure key generation. So a good hardware-based random number generator is absolutely essential to secure key generation. Well, now for the first time in actually a great number of years in Intel architecture, we actually have a good high-quality random number generator that's kicked in with the current generation of Intel Xeon CPUs. So these are the E5, 24, and 26 V2 CPUs that were codenamed Ivy Bridge. So what we have in here now is what Intel calls the digital random number generator, or DRNG. This actually uses an entropy source in the CPU, so a thermal source that's to a very, very precise level to help generate the actual random numbers versus the pseudo-random number generators that were commonly used in software before. So with this, you get a much higher quality source on par with true hardware random number generators that many third parties have made. And this allows for that high quality random number generated pool that exists in most Linux and Unix systems. So now you can actually, you don't have to get a special third party, whether it be from Cavium or Mindspring or somebody else, to generate your random numbers, to do that very, very high quality source of trusted keys. It does meet the different NIST, FIPS, and ANSI specifications for security, and Intel's actually already done all that validation, and it's already implemented in most of the modern Linux and Unix kernels and is coming to Windows soon. And also, as I mentioned earlier, a lot of the FIPS 140-2 certified secure self-encrypting drives have their own hardware random number generator built into them, which is accessible via API. So if you happen to be using any of those technologies, you can also use them as a dedicated third-party random number generator, which combined with either Intel's digital random number generator, you can use it as a second entropy source, or you can use it as a standalone entropy source if you happen to not be using the latest generation of Intel architecture CPUs. So. And then we move on to our last topic, which is around the data encryption and the enhancements there. So the number one thing and something you get for free is AES-NI, or AES new instructions. So this was actually implemented in the last major generation of Intel architecture, and it's been carried through all the modern processors. So it started with the Xeon 5600, which was codenamed Westmere EP. But what this is it's a set of new instructions that Intel added into the CPU specifically to accelerate AES algorithms. And so it's much like the MMX or SIMD instructions that boosted multimedia, except it's a specific set of 6 instructions that were just around enhancing AES. This is one of those areas where just by making sure your kernel and packages are up to date in your distribution can ensure you can get some very large performance increases when doing AES in software. 300% is actually not unheard of, with specific AES functions actually going as much as 1,000% faster when using these instructions when compared to the previous generation Intel architecture that did not use them. So this is where we strongly encourage folks to make sure your distributions and packages like OpenSSL are up to date, and you can instantly start taking advantage of this. Also, there's quite a few options for add-in cryptographic accelerators, whether these be, Intel has their own Cave Creek and Coleto Creeks, as well as guys like, Cavium with their Nitrox 3. If you need to go beyond what you can do in software on the system, which tends to be kind of around the 10 gigabit per second mark if you're doing something around IPsec, then we do have third-party accelerators where you can actually get up to things like 50 gigabits a second of IPsec by just putting in a 25-watt add-in card and using some of the Intel instructions. So without going really exotic or having to go to a multi-system cluster, which can get a lot more complicated, just by doing an add-in card with a co-processing accelerator, 25-watt card, no exotic cooling needed, you can actually get data throughputs up to 50 gigabits per second. And last, I did want to touch a little bit on the next generation, which was codenamed Haswell. So this will be in the E5 2600 V3 CPUs that you'll see before the end of the year and all the next generation platforms. There's actually now, to go with AES NI, you now actually have crypto NI. So crypto NI is another set of new instructions, or crypto new instructions, specifically around speeding up public key and SHA algorithms. When paired with AVX2, which are advanced vector instructions 2, this can actually greatly speed up 256-bit and 128-bit buffer performance for SSA, but also give you anywhere from a 15 to 100% performance gain when using SHA, AES, and RSA algorithms versus today's Sandy Bridge architecture. So how much performance increase you get is going to be specific to the functions you run. Some are accelerated at more 15%, some are closer to 100%. But this is where it's also key, especially if you're looking at a refresh design, to make sure that you're in the latest, greatest iterations of both your packages and your kernel to ensure that you're not just leaving all this performance on the table by just moving your code to the new platforms. So with that, I want to make sure security is obviously a very important concern of the hardware OEMs. That's why they're adding all these features into the hardware for developers to take advantage of. And just remember, to take advantage of these features, you really need to make sure that your kernels, or if you're writing your own code, your code, and especially those packages, things like OpenSSL, are all up to date on your platform. And just remember too that many of these enhancements, they're available for free or very low cost to you with just those code updates. So with that, I'd ask if there's any questions. I think we got a couple minutes where we could take any. No? No brave souls? Yeah, go ahead. Okay. Mm-hmm. Yeah. Yeah, so when it comes to self-encrypting drives, and as I mentioned, they are fairly new technology as far as a standard went. So if we went back, looking at self-encrypted drives 2 years ago when they were in their infancy, there were very, very tight coupling between hardware controllers, software packages, and which type of what they called then full encrypted FDEs, so full drive encryption. But the SED category is now an actual industry standard, so there's much, much better support between hardware, software, and the actual storage devices to ensure that you don't run into those type of incompatibility problems again. Mm-hmm. Yep. Yeah. So that's why it's important to work with a great partner like UNICOM Engineering, so we can do all that validation for you and ensure there's no incompatibilities between the system BIOS and the hardware. Great. I believe we are out of time, but if anyone has any other questions, I will be around for a few minutes, and I'll be more than happy to talk to you. Great. Thank you very much. Enjoy the show.